We human, we're always fascinated by something, and that is colors. When you see different colors, you are always we the way we are designed to appreciate colors. Is that okay? But what makes you to see a color? One aspect of light wave is dispersion of light, and dispersion of light is what actually brings about the different colors that you see. Okay, so and that's what we're going to discuss in our class for today. So today we're going to look at dispersion of light and electromagnetic spectrum. So we'll look at the spectrum of light, the different colors that makes up the spectrum of light. Then we'll also look at the electromagnetic spectrum, the different waves that are in the electromagnetic spectrum. Then colors of white light, the colors that makes up a white light. Then we'll also look at color mixing, and then the combination of different colors of light that will give you different colors too. Then we'll look at the appearance of objects in different colors of light. So that is what we're going to discuss, and this will be the last topic for our discussion on light wave. So I hope you have been following us since we started discussing light wave, and you have benefited a lot. So if you have, please click on the subscribe button, click on the notification bell so that when we upload any other video in other topics, YouTube will notify you, right? This is Nobleman Science Tutors Online, and I am Michael, your online tutor. You can also reach us through the WhatsApp number that is showing right on your screen. Alright, so thank you so much. We appreciate you for your time. Give us a like, give us a thumbs up so that you continue to encourage us. Share this video, invite your friends, and tell them about what we are learning on YouTube. Okay, right. So if you have your writing materials, we'll go straight to our class for today, and that is dispersion of light and the electromagnetic spectrum. So as I said, light that you see appears white, but it is actually made up of different colors. Yes, the light you see from the sun appears white, but it is actually made up of different colors. So it is those different colors, when they are combined together, that gives you the white light. So dispersion of light is the separation of white light into its component colors by a prism. So just like what this picture depicts, this is white light. When white light is incident on the prism, it will be deviated until when it comes out of the prism. As it is coming out of the prism, it is separated into the component colors. And this band that you see is called the spectrum of light. So the spectrum of white light is made up of 7 colors, and they are the red, orange, yellow, green, blue, indigo, and what? And violet. So when you see a rainbow, you see that rainbow is made up of 7 colors, and these are the 7 colors that makes up the rainbow, and they can be abbreviated as Roig-Biv. Roig-Biv. For ease of remembrance, remember Roig-Biv. Red arrow stands for red, O stands for orange, Y for yellow, G for green, B for blue, I for indigo, and V is for violet. So these 7 colors of light makes up the visible part of electromagnetic spectrum. This makes up the visible part of electromagnetic spectrum, which I'll come to that later. So this is the white light that is deviated, and if you look at it, you find out that amongst all these components of the light, the red is least deviated while the violet is more deviated. So diffraction or dispersion is as a result of refraction of light rays, or as they travel from this medium. It is caused by the different speed of the light as it passes through the glass medium. Okay, so dispersion of light is due to the fact that different colors of white light travels at different speeds through a glass prism. Alright, so take note of the colors of white light Roy beef. Roy beef. Okay, so this is your electromagnetic spectrum. The electromagnetic spectrum consists of different radiation which are arranged in order of decreasing wavelength and increasing frequency. So in the electromagnetic spectrum, radio wave has the highest wavelength and the lowest frequency. Gamma ray has the least wavelength and the highest frequency. Okay, also the gamma ray, they have the highest energy, while radio will have the least energy. So if you look at this diagram, this gives you the radiations that are on the electromagnetic spectrum. One is radio wave, followed by microwave, followed by infrared, followed by the visible light, then ultraviolet, X-ray, and gamma. So we have 1, 2, 3, 4, 5, 6, 7 radiations that makes up the electromagnetic spectrum. This is the visible light that I mentioned. Then if you look at it, you see that the radiation, they are arranged according to decreasing from radio wave to gamma ray. You have decreasing wavelength, you have increasing wavelength from radio. The radio will have the least wavelength, gamma ray has the highest wave frequency, radio will have the least frequency, radio will have the highest frequency, gamma ray has the radio will have the highest wavelength, gamma ray has the least wavelength. Radio will have the least frequency, gamma ray has the highest frequency. Okay, and that is what this arrow is indicating for you. This is decreasing wavelength, increasing frequency. Okay, so this is the electromagnetic spectrum, and the one that really affects us more is the visible part of the spectrum. Then we have the infrared and then the ultraviolet. Okay, so please take note of this, and you can even try as much as possible to memorize it. So as I said, the basic colors of white light, we have primary and secondary colors of white light. Okay, so white light comprises primary colors and secondary color. The primary colors of white light, they are red, green, and blue. Now when all these colors are combined together, it will give you white. It will give you white light. Okay, then secondary colors, you get them when you combine any of the two primary colors. So for the secondary colors, you have yellow is gotten from red and green lights. So where a red light and green light are combined, you have yellow color. The red and blue will give you magenta color. Blue plus cyan, blue plus green will give you cyan. So all these are secondary colors, while these are primary colors. Alright, so please, you need to take note of that. So we have what is called color mixing, additive color mixing. Additive color mixing is the mixing of primary light colors to produce other colors. So just like we discussed before, red and green, yellow color, blue plus red, magenta, and blue plus green, cyan. So this is a color triangle also depicting what is here, that when blue and red, that means you have a magenta. When red and green, you have a yellow, and blue and green, we have cyan. Then when you combine red, blue, and green, you have white color. Also, when you combine green and magenta, you have white color. Yellow and blue, white color. Red and cyan, white color. These colors that you combine together to give you white color, they are called complementary colors. So any two colors that you combine to give you white is complementary color. So red and cyan, they are complementary. Blue plus yellow is complementary, and green plus um, magenta, they are complementary colors. Okay, so these are examples of complementary colors, and that's what I've explained you already. So that is additive color mixing. Then you have subtractive color mixing. Subtractive color mixing is used for paints. You know, when you want to paint somewhere, you mix different paint color, and that one is subtractive color mixing. Additive is for mixing of white light color, of light color, but additive for mixing of paints. So for paints, you have their primary color. Primary color for paint is red, blue, and yellow. For light, it is red, blue, and green. But for paint, it's red, blue, and yellow. The secondary color for paint is when you mix two primary pigments together, what you will have is a secondary color. So like here, a red, if you want to have an orange paint, you bring red, bring yellow, and mix them together, you have orange paint. You want to have a green paint, bring blue and yellow, you have a green paint. If you want to have a purple paint, red plus blue will give you purple paint. So if you know how to do those mix, you can actually produce your own paint from this simple something. So this is the color triangle too, as we did for the other one. Okay, so red and yellow, orange, red and blue, purple, blue plus yellow, you have a green. Then if you combine red plus blue plus yellow, you have a black color. Then red plus green is black, blue plus orange, black, purple plus yellow is black. Okay, so these ones are also called complementary colors. This one that gives you black color, they are complementary colors. Okay, so this is your color triangle for paints. This is your color triangle for paints. So having done that, we'll now look at some other areas of this application. So this is color filters. Color filter, they are substances that allow their own color of light to pass through them, while when white light is incident on them, they are actually made of glass or plastic. Okay, so like here now, when white light is incident on a primary red, we know that red is a primary color. So assuming you have a primary filter that is painted red or that is red color, and then you incident white light on it, if white light enters into this, it will allow only the red, because red is primary, it will allow only the red to pass through. So this filter will allow only red to pass through, while it will absorb the other two colors. It will not allow these two to pass, it will absorb these two and allow only red to pass through. So if you have a red filter, if a white light is incident on it, you have red color. And what this also tells you is that if you look at a red color, a red shirt in the sun, the shirt will appear red because the red shirt has absorbed all the other color and it will reflect only red to you. That's why you see that a red shirt will appear red under white light. Okay, even if you put a green here too, green shirts will appear green because only green that will allow to pass through. That's why when you put on a green shirt, it will appear green only, because green is a primary color. But if you have a yellow cloth, we know that yellow is made up of what? Red and green. So if the filter is yellow and white light is incident on it, you find out that you will see that this filter will appear yellow. Why? Because it will allow red and green to pass through it. As far as it allows red and green to pass through, the filter will appear yellow. Okay, so this is one area of color reflection to the human eye. Okay, a combination of red and green will give you yellow color. So when you have a yellow filter, it will also allow the component colors that mix it up to pass through. So for this filter, it allows red and green to pass through while blue is absorbed, because yellow is made up of blue and red. Yellow is made up of red and green. Yellow is made up of red and green, not blue and red, please. It's a typo error. So it's made up of green. It's made up of green and red. Okay, even if I don't write that clearly, but please take note that this is made up of green and red, not blue and red. Because that's what we have here, green and red. Blue is absorbed. Blue is absorbed. So this one is a typo error. Thanks. So when white light is incident on objects of different colors, the color that is seen depends on what the object reflects. Okay, so when white light is incident on an object, it either reflects or absorbs some or all of the light. Thus, an object's color depends on which color of white lights are absorbed or reflected. So, like now, a red object will appear red because it reflects the red light and absorbs the other colors. Okay, so if you put on a red shirt, it is appearing red to you because it reflects only the red color and absorbs the rest one. Same thing with a green leaf. Don't forget that red and green, they are primary colors. So yeah, then an object appears white because it reflects all the colors of white lights. A black object appears black because it absorbs all the colors of white light and does not reflect anyone. Okay, an object will appear yellow in white light because it will reflect red and green and absorb blue. Then a green object in red light will appear black because it will absorb the red light color and no green will be reflected. So this is how objects actually appear in white light. So this is how objects appear in white light. Now I have a summary chart that I will just show you. So this chart gives a summary of all that we have discussed about the color of objects in different lights. Okay, so if you have a white object and you pass a white light through it, the object will appear white. Under white light will be white. Under red light will be red. Yes, under red light the object will be red. Under blue light will be blue. Under green light will be green. Under yellow light will be yellow. Cyan light will be cyan, and under magenta light will be magenta color. Then a black object will appear black in all of them too. Yeah, because there's no color to reflect, so it will appear black because all the lights are absorbed, all the colorful light are absorbed. Then a red object on a white light will appear red. A red object on a red light will appear red. A red object on a blue light will be black. On a green light it will be black. Because these ones, they are not components of red. Then a yellow. Red is a component of yellow, so it will appear red. Cyan, there's no component of cyan or red in cyan, so it will appear black. Magenta. Red is a component of magenta. Okay, red is a component of magenta because we know that red plus blue color will give you magenta. red plus blue will give you magenta. So red is a component of magenta, so it will appear red. For a blue object, under white light will be blue, under red light will be black. Then under blue light will be blue, under green light will be green, under green light will be black, under yellow light will be black. Then under cyan it will be blue, because blue is part of cyan. Magenta, blue is part of cyan, so it will appear blue. So please, you can actually go through this chart. This chart is very, very important for you. So here somebody can tell you that how will a blue shade appear in a green light? A blue shade will appear black in a green light. Okay, a blue shade will appear black in a green light. Then a blue shade or a green shade will appear green in a yellow light. So these are questions that are normally asked in different examinations. So please, you need to try to study this and then try to know it. Okay guys, so thanks so much. I think this is where we are stopping in this particular topic, and thank you so much for your time. I hope we have been able to make you understand some areas that has to do with light wave. So thanks. So please guys, if you have not subscribed to this channel, please subscribe to this channel, give us a thumbs up, give us a like, and then reach out to us through the WhatsApp number that is showing on your screen. If you are a new visitor to this channel, thank you so much for coming. You are welcome to this family. We are doing our best to make physics simple for you as much as possible. So if you have any problem, just call us. We'll see what we can do to assist you. Okay, so thanks so much for your time. We appreciate you. Give us a like and thumbs up, and help us to also share this video and share the information that I hear. Thanks, and see you in our next class.